Hey, welcome everybody to Making Connections. It's the Antaira Technology Podcast. With me, Paul Roberts, your host. Together, we're going to explore the strange world I've never seen before. And we're going to find out from the people who are really making connections in this industry happen. And today, we're privileged to have with us from Antaira, one of their field application engineers, the people out there in the front lines, in the trenches, making it all work, Jonathan Cha. Welcome, sir.
Hi, thank you for having me, Paul.
Okay, we got to do a little explanation here. If nobody has ever heard of Antaira before, what does Antaira Technology do? What do you guys do?
Sure. I think the simplest way to put it is Antaira does industrial networking. So it does networking in the sense of like making connectivity with like the internet side of things, but we're working specifically with industrial applications.
Right.
Yes.
All right, so I hear every day that there's a new world coming, and it's called the Internet of Things. Everything from my toaster and TV and refrigerator to every little piece of equipment on the shop floor or at the top of a oil derrick or the bottom of an oil well or in a traffic light or something, all of these are going to have some sort of little sensors, some sort of little computers in them. They're going to measure, they're going to monitor, they're going to run applications, and somehow they all got to connect to the internet, right?
Correct. So us as a species, I think, like to gather or like know what we're about.
Yeah.
So this whole industrial or this whole internet side of things is collecting information on everything that we can, including all the inanimate objects like a traffic light or a street, for example.
Yeah, they're going to have sensors maybe on the streets and stuff, so
exactly.
the car can tell where it is. It's a self-driving car maybe someday. So it's funny you say as a species we all want to gather. Is this species of what we used to think as inanimate things, are they sort of a new species taking over, populating the planet? Robots, gadgets, gizmos, C-3POs of all different sizes. Is it really Star Wars where there's little robots helping us do everything we do, or little sensors monitoring every piece of equipment?
I think there's almost two sides to that, right? There's a new development side of that where you could say that's like the Star Wars, Star Trek side of things, where things are brand new, robotic androids. But there's also the side of the old stuff that we already have that we're trying to bring new life to.
A refrigerator.
Yeah, or a toaster, old sensors, things that have been installed for 15, 20 plus years that are on the road or in the field already. We're trying to bring those to the light of what technology is now.
Somebody said, for example, and I know this is maybe beyond what you guys do, but because you don't build the sensors and the measuring monitors and all that kind of stuff, you're just trying to connect all those little devices to the internet. But somebody said in a car today, there are, I don't know, pick some crazy number, 100 computers, 200 sensors. There's all sorts of, and they all have their own little systems. They all have their little software. And they don't really, because they weren't designed that way, they don't all talk to each other. They don't all communicate necessarily with the internet. And suddenly they're going, well, wait a minute. Like GM's original OnStar system, we need to connect these things. There's data there that we should be collecting. And then the question is, how? So it would seem pretty simple. We all have routers. Can't we just buy little tiny routers and just hook them up to the internet to some Wi-Fi signal and poof, there we are? What is so darn difficult about hooking this stuff up to the internet?
Well, it wouldn't be that simple. Otherwise, you probably wouldn't have me on the show.
Right? I know that. So I know there's a bigger story here. That's what I'm trying to get at.
Yeah. So the whole thing with the industrial side or automation sides, like let's take your car, for example. Those are more harsher environments, so they require certain standards or certain specifics to be ran at.
So unlike my house router, it's in the snow, it's in mud, it's in dirt, it's in severe temperatures. These things have got to perform under severe circumstances here.
Yes.
And I take it the little normal routers that are sitting in my house or this studio aren't up to that task.
Yeah, we've actually had customers, tell us that they bought stuff from Best Buy, a Best Buy router.
Sure, why not?
And they complained to us saying like, "Hey, our Best Buy router broke. I think we need to go with you guys now. Something more industrial."
Maybe a little more industrial.
Yeah.
So is it just? Let's talk about that before we talk into some of the questions that they bring up here, because I know we want to get to some of those.
Sure.
So an industrial router, that seems to me more rugged. more durable? Is it the case? Is it waterproof?
Exactly.
Is it that kind of stuff?
A lot of it has to do with the casing itself, right? The externals of it are more hardened, ruggedized, as you say, to withstand really cold temperatures and
Or you
really hot
drop them, or you
temperatures.
bang them, or you bump into
Exactly.
them and stuff here. Yeah.
There are certain standards of testing, how much, how far you can drop it.
Right.
The durability of our devices are all tested in that sense.
But it must be more than that, because otherwise you'd just be a box maker here, and somebody
Right.
else would be making the internet connections. It also has to be reliable. If we're talking about, for example, oil rigs. I know they measure these things now. I don't know. I don't know where they measure them. Down in the pipe? Do they stick something way down in the pipe and measure the drill or the flow of the oil and all that kind of stuff?
Yeah, of course they could do stuff like that. Water treatment plants, obviously,
Water treatment, there you go.
they measure like the purity, the levels of the waters, all that stuff. Buses, for example, measure. Buses are easy, right? They measure how many people get on the bus
Yeah.
versus how many people get off, and stuff like that.
So not only does it have to be reliable, it's got to work in severe circumstances. It's got to work all the time. That oil
Right.
rig can't go down because a little sensor failed.
Right, exactly. These are critical environments that sustained everyday lifestyles for a community or
The
small
water
homes.
gets shut
Yeah.
off. Something happens if these little sensors and devices start failing.
Exactly, and that connectivity that we're providing is not only giving those industries the collection of data, but it's also giving them access to control
Yes.
what they have there.
Right. Turn the flow off. Turn it off.
Exactly.
Do something here. All right. So it's got to be in a severe environment. It's got to be. It's critical. So do you have backup systems and stuff? Is it just one little thing? Is this like a rocket ship to the moon? Do they build redundancies and backups into these things?
That's a good word, redundancy, right there. So there is something called redundancy within like industrial networking or networking in general. It's sort of like a backup or a back chain for that.
Because I can't have it go down. We can't go out,
You're right.
drive all the way out to the oil field in the middle of the ocean or the middle of Alaska and stick something down there and figure out, well, here, it's got a little some gunk on it. It's stuck. It's not working here.
Yeah, or you have guys that have to climb a mountain to get to whatever's broken up there
Yeah.
because they didn't have some sort of redundancy or their device wasn't rated to be in that high temperature of that altitude.
So severe circumstances, critical applications that can't fail. And then the one I'm sure nobody wants to talk about, but we're all hearing about, is hacking. Bad people get into these things, and suddenly the gas line, what was it, the Capitol gas line in the whole East Coast goes down because somebody shuts it down.
Right, and that is a huge concern, right? Considering that, the automation and industrial side of networking hasn't really been up to date compared to how we have.
I didn't care if you
commercial.
hacked into my printer or something. Go ahead, have at it,
I mean, some people would care depending on if you want to share your printer or not, but
Right.
yeah, everything in automation side or industrial side is, I want to say, very outdated in the sense of like security.
I'll bet, because it's still based on, now my refrigerator talks to the world. And I can even go on and see, and not in mine, but in more sophisticated refrigerators, a little camera in there. I can see, am I out of milk? I'm at the store. Oh, I am out of milk. I better buy some milk here. It plays music. It does other things. It probably does diagnostics. Someday, my fantasy is I'm going to hear a knock at the door, and somebody's going to say, I'm here to fix your refrigerator. And I'll say, nothing wrong with my refrigerator. Oh, no, it talked to us this morning. It's going bad. It's got a little sensor fit. Got a little problem here. The motor's going. Okay, we'll go. I'll show you where it is. No, we already know where it is. We've already got a little, GPS. Exactly. I know exactly where your refrigerator is. In fact, its name is Joe, and I talk to it daily here. And, it sounds crazy, but we're entering into a world where everything could and probably should be connected. But then we've got difficulty. How do we connect it? How do we keep it connected? And how do we keep it from breaking the connection and people breaking into the connection?
How do we prevent anything malicious from happening to that?
All right. So that leads us to today's topic, which is kind of frequently asked questions. Let's look at the chart up there just real quickly. It shows 6 little infographics, 6 of the probably 6 million industries that you guys are playing in. Walk through that little circle up there. For those listening, not walking, we've got a graphic up in the studio for our YouTube version of this, and we're showing some of the industries. And I'm guessing, I'm sort of looking at it, looks like you've got robots and machines.
Robotics, factory plants,
Solar.
We have solar panels. We work with solar.
Transportation, buses, street lights, all that
Yes.
kind of stuff.
Factory automation. A regular factory that pumps out.
Surveillance, securities, et cetera, and then solar. You guys do a lot. So what do you do in solar? What is again? It's just trying to make all these things that are monitoring or controlling, because the panels have to move and they have to follow the sun.
Exactly right.
everything.
The panels have to be pointed at a specific direction at a certain time of day, but it's also collecting data of how much these solar panels are actually like providing in terms of power.
And none of that means nothing if the internet goes down.
Correct. Right. You won't have any access to it unless you're physically there, and that is not something someone wants to do, especially if they have 1,000 solar panels.
Yeah, you can't go out and run a report and download it on a hard disk or a little flash drive and then take it back and read it here.
You could, but it's going to take you at least all day or something more than that.
And how do they get, one other crazy question that I know this isn't you guys necessarily, but so you're the connector, but who provides the internet in the middle of nowhere? How do I get a signal in the middle of the ocean? At the bottom of the ocean floor to measure my oil well or something?
That's where you kind of need like a backplane, either something reliable as like a fiber connection, or a simple copper Ethernet. But there's also wireless, right? So those are like your three medias in terms of like getting back to connectivity.
And then wireless again seems like we're opening the door to somebody capturing that signal. If it's hardwired, it's harder to get into the thing. If it's a Wi-Fi signal, then somebody can make some little magic device that intercepts that and breaks into it. It would seem like, I don't know. It's a world where we're just beginning to understand, and you guys are already playing this. How long have you guys been doing this? For a long time now?
Antaira's been here for about 16 years now.
So this isn't new. You're not new to this rodeo here.
No.
You've been trying to figure this out for a while.
Uh-huh.
All right. So today, I just really want to talk about in the last 5-10 minutes. Give me some common questions. You're out in the field. You're in a variety of industries. Is it those? Did I hit the big three? Reliability, survivability, and hackability or security. I mean,
yeah, in a sense, yeah. Those are three very good points, because without those three, basically our device is like, again, just a dead box out there.
Yeah,
if it didn't have those things.
Right.
Yeah.
Thanks for selling me a dead box out here. Right?
Yeah, and you don't want that coming back to a company like us. Yeah.
No. And do you sell them so somebody else installs them, or do you service them too? Do you just make it, and there must be somebody who designs the oil rig or the piece of equipment, and now they're speccing out how it's going to connect to the internet, so then they find somebody who's not only going to make the sensors or the controllers or all the other whatever little things, control it, measure it, and talk to it, but they must have some sort of specifications then about this internet connectivity here, this internet Wi-Fi, if we're talking about that. I guess, is that the way we would describe it? The industrial network, so to speak?
Yeah, industrial network is a good term to use. There are a lot of players in regards to how this whole process works, right?
Okay, so I was getting to, are there a handful or a lot?
There's a lot of hands that are in play. So we are just focused on the connectivity. So with Antaira, we're just providing the guys the connection from their endpoint device back to the network, wherever that may be.
Are these just sort of hardened routers in a sense? Is that
routers, switches? We have old legacy devices that do, like serial Modbus, very old style protocols.
Whatever the heck that is, that's some way of communication, right?
Yeah, a lot of these industries actually keep use of those devices because they're so expensive to replace.
I never thought of that. So some technology, the way we used to, for example, this is probably a bad example, but a fax machine used to generate a tone, and you had to, put the little on the phone mode, you had to put the phone on so it could hear the tone, and then it got different. And I don't even know if we use faxes anywhere anymore here. Not many, but that whole world of connecting things, or the type of cables, the serial cables and all that kind of stuff. Cables just keep changing all the time. On my home computer, I've gone from a USB-A to a USB-B to a USB-C, and some of them have power now, and then I got to throw out the old cables and the old Apple cables and the new Lightning. That's just in my world. There must be a million old legacy systems, cables, connectors, ways to do this, and you've got to integrate into all these things. You can't just say, sorry, here's ours. It doesn't match with all that old stuff here, that legacy stuff that's been laying around in your shelf, and it's too expensive to change.
It's just like you said, Paul. With you're just replacing one or two cables at your house. That's pretty cheap.
Right.
But you think of these industries, they have 1,000, maybe 1,000,000 cables of that they need to replace.
Right.
That's going to cost a lot.
Right.
And for some of these guys, that amount of cost is not worth it.
So you got to talk to all sorts of strange, old, antiquated
Exactly,
systems and
yeah.
protocols,
And we have to bring it up to what we have now.
yeah, because I want it to be faster. I want it to be safer. I want it to do all this stuff, but I'm still using an outdated, old PC kind of thing from 100 years ago. I'm using a disk operating system in a world of whatever, Apple and other things. I'm using old technology in a new technology world here.
Exactly. I think that's one of the key points with Antaira, or what we do is we bring old legacy connections, old legacy devices, and we bring it up to what we have now. What's new? So we have AC wireless, fiber connections. So you can take your old serial connectors and then bring it up to something like fiber or wireless. You couldn't do that before. That was a lot more difficult to implement.
You even talked about moving from copper, which was the traditional way to send telephone signals or data, little electrons and little packets through a tube of copper here. And of course now they've all gone to fiber, which is
light and glass. Yeah.
Because light doesn't give off any heat.
Right.
And now, but I could understand how they get photons light to bend. I can't make my flashlight bend around the corner here, so somehow they figured out how to make the photons bend and go around bends and corners and all that stuff. But all my cable TV, to the extent I still have cable TV now, I'm wirelessly coming through satellite or whatever, or the internet. But for a long time, we were trying to upgrade from copper to fiber because it was faster and the pipe was thicker and you could put more in it. And yet your device has to be able to connect to anything and everything.
Correct. We have to work with a lot of uncommon sorts of devices.
Do people make their own stuff? Because I hear this all the time in computer systems. So my company's gonna buy your company, and you're on some customized computer software that you've been using to run things or track things or do your accounting or sales or whatever. And it's a system you made. You built it. It was your own creation. Hooray! It did exactly what we wanted. But it was meant to run on Windows 95. It wasn't meant to run on modern systems here. And so somehow my computer can't talk to your computer anymore here.
Yeah, we refer to a lot of those, like custom built or one-offs, or as proprietary devices.
Exactly.
Proprietary
That's
stuff.
the word I was searching for, right?
We do run into a lot of proprietary or legacy stuff like that, and we don't necessarily work with those things, just because, again, they're built to be working in a specific way or in a specific machine.
They never envisioned the things we're going to do with them today, so they're not set up to do that. They don't have the software. They don't have the physical wires and connectors and things that even do it. But sometimes you've got to. That's the way we've been running our oil wells for 100 years. That's the way we've been running the machines here. So now we want to get them online. How do we do that?
We have to either revamp the entire layout of the network,
right?
Or we have to find some workarounds, right? Yeah. Right, because we have a lot of devices that can work in specific regards to that, but a lot of the proprietary stuff is going to stay proprietary.
So give me a couple of common questions beyond security, beyond survivability, beyond reliability. Anything else people are coming up and saying, man, and these legacy weird systems that you got to connect to something, and I know it's old, but you got to connect to it somehow. Any other common questions or frequently asked questions that people ask? I'll bet there's a lot of them. We're not even going to touch them on this show, but give me a couple other big ones there.
I think the big one or the big questions come in regards to wireless. We are starting to really branch out with wireless. We've been mainly focused on switches and hardened switches, routers and stuff like that.
Safer, easier, easier to protect. It runs, it's reliable, but now we got to go on a wireless signal.
Right.
And who knows the strength of that signal or where it's coming from and the safety of that network.
Yeah, there's a lot of misconceptions with how wireless works. People think you just point it at the other end and then that should give you, your direct line of sight. But it's not that simple.
Not that simple.
You have to take in consideration that it's a radio wave. It's an invisible wave that you don't see, but it's in the shape of a football. It's not a direct line of sight, right? Okay. It's called the Fresnel zone.
The Fresno zone.
Yeah, if you guys want to, you can look it up. It's called the Fresno zone.
Poor Fresno. They get all sorts of things associated with them. The Fresno zone, all right.
And it's in the shape of a football. Okay. So it's not a perfect straight line. It's not a perfect circle. It's in the shape of football,
Because
and
it
then
comes out in waves, literally.
yeah. And then any sort of like interference in that Fresnel zone causes drop signals, disruption. So that
We've
includes the
seen
ground.
that in our cell phones, that
Yeah.
sudden sound where it's trying to hand off from one tower to the next, and suddenly it ain't working.
Yeah, if you notice, if your home router is between a wall, your signal is actually weaker between a wall. But you also have to take into consideration the ground. The ground can be interference. Even the air can be interference.
The air can
Yeah.
be interference. Oh boy, you should come back and do a whole show on just Wi-Fi, because I think that's a world we don't understand at all. Again, we just think somehow this signal's floating through the air, and why can't I get it? What's the problem? Why can't my TV connect? Why can't my refrigerator connect? Why can't my cell phone connect? So what if there's a wall? So what if there's this? I don't care. It shoots through it all, doesn't it? It's just a magic signal that cuts through everything.
Yeah, I think that's how Wi-Fi was marketed. It's just like, hey,
Yeah.
there's this wireless thing. You don't have to worry about it. You just turn it on and it should work.
Yeah.
No, there's a lot that is not said.
Well, let's have you come back and delve into that one, because that's where we're all headed. The
Sounds
world doesn't want to be wired anymore here. We all want to be wireless. And in a wireless world, are we really set up to connect everything, anything in this world? I'm not sure we are. Well, that's one more reason we need guys like you. I appreciate you coming in. I look forward to talking about this. Is a world that we're just beginning to wake up to. Traditionally, they call it the Internet of Things, where it's not the Internet of people anymore, connecting people to people. It's connecting devices, computers, chips, sensors, all these inanimate things that surround us, the machines that run our worlds for us here.
Correct.
And we now want to have them completely online, so we can access them, so we can monitor them, we can read them, we can get the data from them, and we can do something with that to make the world a better place here.
Yeah.
But in the process, we got to have people like Jonathan Shaw here, a field application engineer for Antaira. Thanks for joining us here today.
Thank you, Paul, for having me.
Okay. Well, there you have it, folks. It's time to strap in, strap on, and make a connection right here with us in the Antaira podcast. Produced by Orange County's only community radio station, OCTalkRadio.net. Okay, there we go.
How'd that go?
That's what I'm looking for.
You make it so easy, Paul.